Hello, what's up, my friends? Today I'm going to talk about a very interesting topic, which is motor as a generator. How can we use motor as a generator? So, what is basically a generator? Generator is basically a device which generates voltage when a mechanical force is applied to it. So when this is the configuration I have used, this is the motor which is used by rotating with a PWM circuit, and this is the motor which is acts as a generator. I have connected the shaft between the two of them, so in order for them to rotate synchronously. This is the LED, this is the resistor, current emitting resistor. This is the configuration. Basic, I call it a dumbbell shape, but think of it as a dumbbell. So this is the configuration I have used. Now the circuit I have used is that the PWM control for motor. But before going to that, we will talk about what is a generator. Generator is basically a device which basically generates a voltage, as I have talked. But how does it generate the voltage? So when the magnetic field, basically inside this motor there is a rotor and a stator. So rotor is basically connected to this and it rotates, and stator is keeps in its position, stays in its position. So the rotor has magnets on it, whereas the stator has a coil on it. So when we apply mechanical force is basically a torque through this motor to this motor. It rotates synchronously with this motor and the shaft turns. So generator is produced when a magnetic field, a coil is cut through a magnetic field at 90 degrees. When a coil cuts a magnetic field at 90 degrees, then and then only the generator is created. So we will talk about the circuit now. And this circuit is basically a different one. PWM control with motor with generator. This is a advanced circuit. Basically, we connect here VCC. We can use 9 volts, 12 volts, basically 5 volts. But later I will use LM7805 to convert into 5 volts. You can use anything. Now this is the voltage divider which is connected to the positive terminal and the 10k ohm to the feedback. So this basically forms a feedback, a Smith trigger. Through feedback it forms a Smith trigger which reduces the hysteresis and it maintains the state. This is the inverting terminal which is connected to a 10 nanofarad capacitor and a 10 kilo ohm resistor, which we will talk about the calculations later. This is the input pull-up as mentioned in the data sheet of LM393. I have used LM393 as an op-amp. So this produces a square wave, but this produces a triangular wave as the capacitor charges and discharges. So I will basically let you know in later. Then I have compared the wave using another op-amp with the triangular wave is compared with the DC offset created by this VCC. They are connected to the VCC and ground the output pull-up, or basically the input pull-up. Anything you can use. This is the MOSFET which will drive the motor. But I have used an advanced circuit instead of this. I have used this. This is the LM7805 which is used as a voltage regulator. You can use also LDOs for it. This is the 100 kilo ohm as mentioned. The all remains the same, but here I have used the push-pull configuration of the transistors and a signal diode in order to pass high frequencies, because we are using kilohertz frequencies, 10 kilohertz, 9 kilohertz, 15 kilohertz, 20 kilohertz. This is the push-pull configuration, so it lets the high side to pass through this and low side to pass through this, which eventually forms a wave, basically a PWM which will drive this MOSFET and the motor. This is very important. You can use 1k resistor or 500 ohm resistor. This is gate pull down resistor. In order for the gate to be at the ground, because this is an N channel MOSFET and we have to apply VGS as positive voltage. This I have circled because this is very important. This creates DC offset as well as it also creates the PWM we require for the MOSFET to drive. So here is how a stable multivibrator or using op-amp or a relaxation oscillator we can call it. This is the waveforms Vset minus Vset, and the formula is T is equals to 2 RC into ln 1 plus beta and 1 minus beta. Beta is known as a fraction feedback which is created by the hysteresis, or which is created by the Smith trigger. This is the transient analysis of the capacitor. This is the calculation, and finally we come to the conclusion, and I will show you how this circuit works.